Let's tackle this question. Kathy is estimating the orbital radius of Saturn. She found that it takes 90 days for Saturn moving from opposition to eastern quadrature. Give the orbital period of Saturn is these days. And first, the question wants us to sketch the motion of Saturn from opposition to eastern quadrature and then calculate the orbital radius of Saturn. So basically, let's start with drawing a sketch. So I have already drawn you a sketch. The middle is the sun, next is the earth, and then the Saturn. What we found is that the opposition is when the earth and the sun and the Saturn align in a line like this. So this is called the position of opposition. So the observer, like here at midnight, the Saturn will be at the observer's zenith. And then next, after the earth revolves around the sun for some times, because following the right hand rule, right, the earth will move about here, right? And another interesting position is that when the observer on the earth at the sunset, because the earth is rotating this way, so at the sunset, what we are interested in is the position of the zenith. So this position where the Saturn is the position of eastern quadrature. And so we have already successfully done the first part of the question, which is to sketch the movement. The Saturn will move here, right there. And let's add in some details from our sketch so we can calculate the orbital radius of Saturn. So what we find out is that this angle here is 90 degrees, right? And we can draw a triangle from Saturn, Sun, and Earth together. And we're interested in this angle, which we call beta. We know that the Earth from rotation of the Earth to the Earth in the future, right, is actually has its angle, let's say theta E, and the Saturn to the new Saturn is theta S, right? So from this curve we can find the equation that beta is equal to theta of Earth minus theta of Saturn. And basically we know that the orbital radius, the orbital period of the Earth is 365.25 days, right? And since it takes 90 days from the Saturn to move from opposition to eastern quadrature, so it will be 90 days overall times with 255 or 25 days orbital period, and then times with 260 degrees. This is the theta of the Earth. And then we're going to minus with the 90 days again, but the orbital period of Saturn is 759 days, and we're going to times with 360 degrees as well. And from the calculation we can obtain the angle beta, which is approximately equal to 85.69 degrees. So after we obtain beta, let's consider this rectangle over here. Sorry, this triangle. We have this angle beta. This one is 90 degrees. And we know that the distance from the sun to the earth is 1 astronomical unit, right? And the distance between the sun to the Saturn is, let's give it as L. And we're going to use the trigonometry to help us find the L. So we're going to use cosine beta is equals to 1 atomic unit divided by L. So that means that L is equal to 1 atomic unit divided by cosine of 85.69 degrees, which is equal to approximately 13.3 astronomical unit.